we copy and paste our second degree. And we add C3 times x minus a cubed. And now we got to go through all of this again. And since we're on the third one here, that means there's another condition. The third derivative has to equal the third derivative of the original function, evaluated at a. So I'll do it faster this time. P3 prime of x, that'll be 0. When we bring the 1 down and subtract, that'll be to the 0 power, so that'll be 1. So we'll just have this f prime of a here. Okay. When we bring down the 2, it'll cancel with this 2. X minus a, subtract 1, now it's to the 1. This is where it's all gonna, pay attention here, guys. As we go through this, it's all gonna click. The little piece that you're missing is going to show up here, okay? When you bring this 3 down, and we get 3c3 x minus a squared, all right? We won't go through all that. If you put a in there, this will equal f prime of a, no problem, because those go to 0. Now let's find the second derivative. The derivative, that's a constant, derivative of that's 0. Bring down the 1 and subtract 1, that'll become to the 0 power, which makes that 1, so we have f double prime of a, plus, here it is. Bring down the 2 here, and what do we have? We have 2 times 3, don't we? 9. Huh? 2 times 3 is 9?
Oh, no.
3 square is 9.
6.
3
Plus,
square.
Okay, look guys, what did we bring down here? We brought down a 1, correct? Now we're bringing down a 2. Oh, then we brought down a 2. Yeah, now we're bringing down a 2. Let's do it. So I'm going to write it as 1 times 2 times 3. C3 x minus a to the 1. Actually, I'm going to write that as 3 times 2 times 1. Maybe that'll make it more clear. Actually, let's just write 3 times 2. The next one will bring down the 1. Here we go. Now let's find our third derivative. The derivative of that is 0. Now we're bringing down a 1. So we have 3 times 2 times 1, C3 of x minus a to the 0, which is just that. What's going on here? 3 times 2 times 1.
Factorial.
3 factorial. Yes. 3 factorial is what's going on there. So the requirement is that this is equal to the third derivative of the original function evaluated at a. So 3 times 2 times 1, C3 has to equal f triple prime of a. This divide by that, C3 is f triple prime of a over, I'm going to write it as 3 factorial.
Oh, man.
All right?
I knew that. No.
So, P3 of x will be, starts right here, f of a plus f prime of a times x minus a plus f double prime of a over 2 x minus a squared plus f triple prime of a over 3 factorial x minus a cubed. Put that in for the C3 here. Now guys, look. This is 2 factorial. I didn't talk about it then, but it was 2 times 1. That's 2 factorial. This is over 1 factorial. This is over 0 factorial. And what did we say 0 factorial has to equal?
1.
It has to equal 1. So that's over 1. We don't write them, but that's what it is. You got it?
And 1 factorial is also 1 too, right?
Yes, 1 factorial is also 1.
Just making sure.
So what's the next one gonna be if I do a 4th degree?
Four
Yes.
factorial
It'll be the 4th derivative,
times
f
x minus a.
quadruple prime of a over 4 factorial x minus a to the 4th. So,
Let's do
you guys
it.
see the pattern now? If you see the pattern, we were successful. All right? We were successful. Okay, can I erase this? Again, I'm not gonna ask you for any of this, I'm gonna ask you the nth degree polynomial piece of n of x is going to be, basically I'm gonna copy that over there. F of a plus f prime of a, x minus a, plus f double prime of a over 2 factorial x minus a squared, f triple prime of a over 3 factorial x minus a cubed plus dot 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 plus the nth derivative over n factorial x minus a to the n. So all of that was to develop this. And you don't have to be able to develop this. I hope you saw the pattern. I hope you saw where the factorials and everything come from. The condition is that when we evaluate this at the original value, that and the function value agree. When we evaluate the first derivatives, they agree. The second derivatives, all the derivatives agree. Okay? What time we got? I'm gonna do one example with this. We don't need any of this. I'm gonna erase this stuff, okay? Sorry, I got a rough start on it. But hopefully it all makes sense now. All right, let's approximate f of x 1. Okay? F of x equals ln x at x equals 1. Please write your notes exactly like I showed on the board here. And I have a process here. So let's first start out with a linear. So we're only going to go up to there, to the 1 power. That would be quadratic to the second. So we're going to do a p1 of x. Write the original function here. And then find its derivative. Derivative of natural log is 1 over x. If we were asked to find a quadratic polynomial, then we would find a second derivative. Remember, 1 over x is like x to the negative 1, so the second derivative is negative 1 over x squared. And if we're asked to find a third degree, we would find a third derivative, and we're going to do these. So that would be like negative x to the negative second. Bring the negative 2 down, it becomes positive 2 over x to the third. So make a vertical list like this, as far as it needs to go. If you're asked to find a 5th degree, then you're going to go 1 more. Put a little, no, 4th degree, I'm sorry. Put a little 4 up there. That'd be x to the negative third. Bring the negative 3 down, that becomes negative 6 over x to the 4th. Then, evaluate each of these at this value that you're given. So f of 1, that equals ln of 1, which is 6 over 1 to the 4th, which is negative 6. So make those two lists. The original function with the derivatives below it, the original function evaluated at the given value with all the derivatives evaluated at the given value below it. Now, let's put it together with this now. P1 of x. That's going to go up to here, these right here. F of a, which you have sitting up there, f of 1 is 0. Plus f prime of a, that's the f prime of 1 over there, which is 1, times x minus a, x minus 1. The value that we're approximating it at, this is the a here. So this just equals x minus 1. Let's see what this looks like. Sorry that I'm going so fast, we only have 7 minutes. So we got f of x equals ln x, p1 of x equals x minus 1. Okay, so do you agree that this orange line is an approximation for natural log at 1? Let's get these out of here. What's your question?
Okay, so, in order to find the exact approximation, we will need to find the infinity of it? Is that how?
Yes. But we're not gonna do that right now.
No? Yeah.
But yes, if we carried this out infinitely many terms, it would exactly match all the way from negative infinity to positive. Okay. Do you guys see this orange one as an approximation at 1? Yeah? All right, let's improve that approximation and let's find a quadratic. So the quadratic is going to be P2 of x. It's going to be the linear x minus 1 with the quadratic term added. So when you're doing this in MyLab, before you check it, you're going to want to copy it, because once you check it, you can't go back and copy. And in MyLab, you have to copy by doing Control-C. Right-clicking does not work. Control-C, Control-V. All right? Anyway, P2 of x is going to be this x minus 1 plus the quadratic term, so plus the second derivative over 2 factorial. Here we got it. Our second derivative is negative 1 over 2 factorial times x minus 1 squared. So that's just x minus 1 minus 1 half x minus 1, whoops, squared. Yeah, you can think of this as being a term like that. But let's put that in here now. X minus 1 minus 1 half. Now let's zoom in there. Okay, do you see that this quadratic, this green one, sticks to the black one longer than the orange one does? See that? It's a more accurate approximation when we're close to 1. It'll stretch out a little further and still be reasonably accurate. P3. Oh, here's the pen that writes nice. Copy and paste your P1. X minus 1, those parentheses are optional. And now we add the cubic term. So that is the third derivative evaluated at a. We have that right here. It is 2. Yeah, squared. 2 over 3 factorial times factorial, but it's not necessary because 2 times 1 is 2.
Oh.
Okay, but you are correct. You don't have to put it in there for my lab. All right, let's put this one in. So I'm gonna copy this. Control C, Control V, I'm gonna change that index to a 3. And we're gonna add 2 over 3 factorial. Now, 3 factorial is 6, you could reduce that, but just for the point here. And let's turn these off because it's getting kind of cluttered. And let's make this one orange. So that orange graph now stretches the approximation window. That make sense? And we can keep going and going. We can do a 4th degree, a 5th degree, a 6th degree using that pattern up there. You guys got that? These are called Taylor, well, we're not series yet technically. Taylor polynomials. So the reason why it's a polynomial, Taylor polynomial, is because we're going to the nth degree. If you went to infinity, then it would be a series. Does that make sense? If you say the word series, that means you're carrying this out to infinity. If you say the word 5th degree polynomial, then it's what it means. Cool? I will post an assignment, but you just worry about finishing up chapter 10 right now. And we will do more examples. This here just introduced it. We'll do more examples for this. We're going to